All right, for December the 3rd lesson, it's been a lot of COVID going around and people having to miss and been exposed. And the best way to do this, I think, we wasn't going to have hardly anybody be able to participate in class at school. So we're going to do this like we did earlier in the year, and I'm going to send you a YouTube video on Mike Holt, the limited energy and communication system. I think that'd be the best way to handle that. Plus, we're going to take the book on understanding the National Electrical Code, Volume 2, and do the exam, final exam B, the 100 questions starting on page 437 through 446. Then you can turn that book into me on the 10th when we have class. And I think that night we're going to try to have somewhat of a lesson. And then I think Russell's class and our class will get together, maybe eat a little pizza to finish up the year. I know it's been a crazy year. Hopefully you've gotten something out of it. I know we've learned a lot on the code book and controls, but in order to progress next year, we're going to have to buckle up. And, man, I hope they get a vaccine out where we're just going to have to be committed to making these classes and staying on track. I hope that's possible. But anyway, I'm going to start out on the communication system from Articles 800 to 820. So I'll send this to you.
Okay, the definition. Point of entrance. And this is a graphic that we want to add maybe back over into 770 that we talked about. Non-listed optical fiber cable coming in a building was not permitted more than 50 feet from the point of entrance. And there was a definition, and we didn't have that graphic in the definitions.
Right.
But we do have the graphic here showing the telephone. So the utility bringing in, or if you're bringing in communications wiring in a building, we need to know where the point of entrance is, and that's where it kind of enters the building. So later on, we're going to use that. Access to electrical equipment behind panels designed to allow access. Well, you know, you need to be able to have access to equipment. So if there's equipment behind, we can't have all these things in front of it. Of course, this is, you know, securing, supporting, abandoned cable. There's a lot associated with this one graphic if we want to sit down and think about it. But let's just put that cover back and we move on to the rest of the project.
That's what it looks like at the hospital.
Equipment and cabling, 800.24, must be neat and workmanship-like manner. You know, Victor says, Mike, you need to add the word violation here. I'm like, why? Because we just took the word violation off. He said, well, that's not neat and workmanlike. And I'm thinking to myself, that actually looks like a pretty good job. But Victor is used to some very professional jobs and is like, no, that's not neat workmanship like. So, you know, we talked about that before. It's a judgment call. Exposed cables must be secured by straps, staples, cable ties, hangers, similar fittings designed and installed so as not to damage the cable. Independent support wires, you got to add for your own communications wiring for the raceways as well as the cables. Keep that 1 1/4 inch separation, as we've discussed, both parallel members here, parallel members up there, parallel members over here. But there's nothing in there when you're running perpendicular, only when you're running parallel. Cable ties, this applies to all the low voltage applications, including 725, 760, 770, 800, and the other ones. If you're putting cable ties in a plenum space, then those cable ties have to be listed. And you have to say it here in 800 because you can't use any of the language in 300 because 300, chapter 3 doesn't apply. Nothing, actually, chapters 1 through 7 do not even apply to chapter 8. So you got to say something here which you want to tell it to be. Mechanical execution work, you know, what is the neat workmanship like? It's the standard, and I think you guys talked about Bixie, and, you know, that's probably the driving force when it comes to telecommunications. EIA, TIA, right? Abandoned cable, 825. The accessible portion of abandoned cable must be removed. And so this is a little bit of a problem, you know. I mean, I've been in the building here, and of course, this is the WorldCom building in New York City. And that's where that generator that was in the basement, that water came up above that. So I got a chance to get into some spaces in there. And not shown here, but I forgot where it was. Somewhere it says cable tray full. I mean, so I'm thinking, yeah. And I'm thinking, how the heck do you troubleshoot that? So I don't know what do you do about abandoned cable and remove it. That's going to be somebody.
Remember I told you don't troubleshoot it. You just stick another cable on it.
Okay, that's right. Okay, that's why we have so many.
You cut off the parts you can see and put a new one.
Okay. And if you want to keep it there, identify it for future use. We played that game over enough times. Spread of fire, products, combustion. Since 300 rules don't apply, 800.26 tells us you have to make sure openings through penetrations through fire-resistant walls, floors, and ceilings must be fire-stopped using approved methods to maintain the fire-resistant rating of the assembly. And Brian, you want to say something about this right here? I think.
I just absolutely love that picture. Somebody just took pride in what they did. They did a very nice job. It's just so often that you see people doing fire penetrations and they do a really just cruddy job. And that's just a very nice job.
Unlisted cables entering a building, 848. Unlisted communications cable is permitted in a building spaces other than rise plenums if the length of the cable within the building from its point of entrance does not exceed 50 feet and the cable terminates in an enclosure or an enlisted primary protector. So 50 feet from the point of entrance.
I know a lot of
Metallic entrance conduit grounding, 800.49. Rigid metal conduit or IMC conduit containing communications entrance cable must be connected to the intersystem bonding termination. So I don't think it's very common today, anybody running metal raceway into a building, but maybe they can sleeve it up a little bit, you know, maybe with a metal sleeve. If that's the case, then you put a bonding bushing and then you put a bonding conductor and you connect it over to the intersystem bonding termination.
Might be some kind of a utility spec, maybe. I don't know. I don't see it very often.
Yeah.
But
and you know what? I was talking to somebody that might be on our team in 2020, and he said, Mike, make sure you cover that bonding of that communications metal race becoming in the building. And we actually had pulled it out of the book because I didn't think it was worth it to cover. And I'm thinking, I said, Brian, we got to put it back in the book because he suggests we did. I'm like, why? He goes, Mike, if there's a lightning event outside, that metal pipe is going to become energized, and there's a difference of potential. So you want to make sure you bond it over to the other one. It's a little different than why we normally go to intersystem bonding termination. And I thought, you know what? That's a good point. Victor?
You might use that just for a 90.
That's what I'm saying. Up. Exactly. So we better put a bonding bushing and a bonding jumper and make that connection to the intersystem bonding termination. Lightning conductors, 800.53. Where practicable, communications cable must be kept at least 6 feet from the lightning conductors. You know, okay, but that's also contained in NFPA 780 lightning protection standard that you really want to keep everything electrical 6 feet away from the lightning conductors. That's to prevent that side flash from going over to that. And so, code's talking about communications, keep 6 feet away. Fair enough. 800.90A. Primary protector. A listed primary protector is required for each communication circuit. The primary protector must be located as close as practicable to the point of entrance. And these are your primary protectors. Basically, Brian, you want to tell us what primary protectors are? Are you familiar with them?
Yeah, it's basically a type of surge device for where the utility cables come in. And the purpose is you've got possibly miles of cable between you and wherever it's terminating on the other end, and you need some way to be able to dissipate surge events.
And we didn't talk about it, but we'll talk about it. Here is your protectors right here, okay? And you can see what? Basically, it's surge protection.
Yep.
It's a take that in the event you have an overvoltage condition because of because of a lightning event charge, it's basically surge protection device, Tom. Mm-hmm. You guys sell these, right?
Sure. Yeah.
This is a big installation, but actually on the next slide even, they actually, you can't really see it, but right there, that yellow thing that's inside of the demarc there is also a primary protector, and that's what people would see on a residential.
Exactly right. And this is a metal sheath of a cable.
Good to know.
It's connected to this grounding connection, which is connected to the intersystem bonding termination. So we're bonding the sheath of that cable, and the sheath of that cable going over to the telephone box is also connected to the metal framing of the telephone box. And that metal box is actually connected to a grounding electrode.
That
ground
grounding
line.
is
So we're trying to
important
keep all
in
this
that
stuff. This is
communication
lightning,
world.
energy. This is not clearing a fault. This is trying to get that energy to the earth. It's equipment grounding, not system grounding. It's just grounding equipment. 800 100. Now we're going to be getting into the very first time talking about bonding and grounding the electrodes. What we're going to be, let me see if I have a picture here. Okay, here we go. Let me go here. Here's your primary protector for the telephone. We have to connect that primary protector to the electrical system. And 21594 requires us to install the intersystem bonding termination. And then we take the primary protector and we connect it over to our intersystem bonding termination. It's just that simple. And it's called bonding. Now, I was saying something to Brian, and I said something to him, and he's like, it was just the weirdest thing that he said to me. And he goes, well, this is kind of crazy. You would never start an article with an informational note. And he was just making a statement. I said, oh, do me a favor. Go to 800.1. So we go to 800.1 if I can eventually get here. Man, won't do that again. Gosh.
Previous.
And 800.1, I said, Brian, do me a favor. Go to 800. I says, what's the first thing at 800?
Even before. Information note.
And he goes, they did start it with an informational note. And it was just so ironic that you said, like you're going to start an article with an informational note. I said, go take a look at 800. See how's it start? And he goes, oh my gosh, which is totally, completely insane. So let's make a public input. Here's what happened. What this says here, hey, informational note. Figure A and B illustrates the application of bonding and grounding electroconductors and communication systems. So then you come over here to the figure. And non-planarated communications, cables and raceways, wires. Communication cables aren't permitted 725, but these should be. Here we go. The cable voltage markings. Basically, what we're talking about is we just want to make sure that we connect all these metal parts,
810.
connect them together. We're talking about antennas, nothing else. Other articles. Coaxial cables that connect antennas to equipment must comply with 820. 820 is coaxial cable. We're not worried about it. Don't go to 810 for this stuff. So we're talking about the antennas. Yeah, 810. Maybe you're going to have some kind of control. It might be 725. Telephone. Okay, well, that's twisted pair wires or conductor. Telephone. That's 800. Antenna, the actual satellite dish. That's going to be 810. And then the cables. All the cabling here. That's going to be 820, which we haven't got to yet. So let's talk about the antenna. The antenna for community
This might be
television
helpful.
systems must be
in a
installed in
residential
accordance
area.
with 810, which is the antenna, but the coaxial cable beyond the point of entry must be installed in accordance with 820. So let's take a look at the language about that, and that's the important part to be aware of. Oh, 1 second. Is that not? It does not say that in 810.
That's your coax. Well, no, that's how it's communicating.
Where does it say that at?
Oh, there you go.
Oh, yeah, it does say that. It just doesn't say it is. It's clear. The antenna shall comply with this article, which is what? 810. The distribution system shall comply with 820, which is coaxial cable. The antenna for community television systems, I remember doing this when I was working in the trade. We just put an antenna on top of a high-rise building. And then we put splitters and we ran down all the wires, all the individual little units. The antenna for community television systems must be installed in accordance with this article because it's the antenna, but the coaxial cable is 820. Just another picture of that same rule. Antenna lead-in surge protectors, 810.6. The antenna lead-in surge protectors must be grounded using a bonding conductor or a grounding electric conductor. That all depends on whether you're going to intersystem bonding termination or not. And Mike, let's put intersystem bonding terminations on this graphic on 810.6. And let's take a look at the rule on 810.6. An antenna lead-in surge protector is installed. Okay, where an antenna lead-in surge protector is installed, it shall be listed as being suitable for limiting surges on the cable. Brian, do you even know what that looks like?
The only thing I can think of is the little, not the grounding block, but they have a
little thing with a wire
it's
came
a cylinder,
in with twisted pair of wires, and then that little tiny thing, like a little strap that went along on the
Yes.
outside.
That's the only thing I can think of.
Yeah, years ago. That's that old stuff.
But I'd be honest with you, to tell you that I think I still know what it is, no.
Support of lead-in conductors. Outdoor antenna and lead-in conductors must be securely supported, and the lead-in conductors must be securely attached to the antenna. Okay, so your wires are going to be attached to the security. You're going to have anything bouncing all over the place. Got it. Antenna leading wires must securely supported. Okay, here's the antenna leading wires. Okay, got
We're
that.
actually, we're going to leave it in.
We are going to leave it in.
Yeah.
Research,
because-
what do they say?
No, there's like 100 of them on Google.
Show us what they look like.
Yeah, got a bunch
So
right
what
here.
we got there. And
We make those.
let's take a look
Oh,
at
and Eaton makes them too, just in case
Just
you
in
were
case you were
wondering.
wondering, we do make those. You have to protect your data, and you have to protect your phone as well as your power conductors. So
that we didn't talk about that, but I don't remember. Oh, yeah, second. With this has to do with the antenna.
Yeah.
And because it's an antenna, high energy, be a good idea to put a surge protector, like we talked about surge protection, emergency systems, elevators on an emergency system disconnect means fire pumps.
Yep.
Yeah, you guys are just all over the place.
Hey, look, there's one of our drawings.
Yeah. I know. Oh, my goodness. Okay, 810.12. Let me take a look at the text on 810.12. Take a look at 810.7. Brian, let's make sure this is in our textbook, and we should add this in a slide. Where bonding or grounding is required, device is used to connect a shield, a sheath, non-current carrying metal members of cable, or metal parts of equipment or antennas to a bonding conductor or grounding electric conductor shall be listed or be part of listed equipment. So I think it's an important thing to kind of mention that. And 810.12 supports outdoor antenna leading conductor securely supported. The antenna leading conductor shall not be attached to electrical service masts. And there it is right there. So that is not permitted. That's for us to do. Utilities, that's another story. 810.13, the antenna and lead-in conductors must be kept at least 2 feet from exposed electric power conductors to avoid the possibility of electrical contact. I can't even imagine how this rule would even apply. Because, oh, you know what it applies? I take that back.
yeah,
It's right up here. So we need to get this graphic right here.
You don't want to
That
mount an antenna on your service.
810.13 is you have
bet
to
it's
stay right
been
here.
done.
What? Well, first of all, you can't do this. So, okay. So we have to find out some example we have
Well,
exposed conductors.
Really easy. If you mounted the satellite dish on the eave, which is like mine's actually screwed to the eave.
Okay,
has
so you put the satellite
internet,
dish
so-
here.
Right.
Then another graphic, and then this could not be any closer to this by 2 feet. Because what's a minimum drip loop over a roof? Anybody know what the minimum height is?
It was 3 feet or 2.5.
We have 2.5. I heard 3. Anybody else? Mike says 18. The answer is 18 inches. So you could have it where that cable could be coming up, and you could be within 2 feet, and that would be a violation. So at 810.13 would be a graphic that we could use, which says that you have to stay 2 feet away from exposed power conductors. Eric.
I thought the 18 inches was to the bottom of the service entrance conductor.
Well, I just said that.
No, you said bottom of the drip loop. If the barrel splices are up halfway up the slope, The 18 inches is up to the barrel splice.
In this case, would you agree it would be 18 inches from this point right here?
Well, because he has the barrel splices down there.
There was a reason.
Whoa. 1 second. What is the rule? Exposed conductors. This is an exposed conductor.
Okay, are we talking about the electrical power conductors?
These conductors right here, they would have to have a minimum of 18 inches above.
Well, except the utility conductors are outside the scope of the code.
Yeah, but I'm not talking about their wires. I'm not talking about the black one. I'm talking about that red one.
Right, and so I'm just saying that if the barrel connector were halfway up that slope.
What we could do is then take these barrel connectors and bring them over to here.
Right.
Right.
Then it's 18 inches
Then the
to...
18 inches would be measured from here.
Exactly.
But those are insulated.
And it all depends on the
No,
utility.
we're saying that if the connection was not made here,
Yeah.
but that connection was made up there,
Right.
then the 18 inches would be measured from our conductors because the utility conductors are exempt.
Right. But in our area, the utility.
There.
Interesting.
There was a reason.
So we don't want to be promoting protection system in my house. He starts laughing. I said, "What are you laughing?" He goes, "What's the lightning protection in your house have to do with anything?" I said, "To protect my stuff." He goes, "Protect what stuff?" I said, "My telephone, my TV system, my modems, my computers, my electronics." He said, he goes, "Mike, a lightning protection doesn't protect any of that." What does it protect? He says it protects the structure. Air terminals, grounding conductors, lightning goes to hit that Faraday cage. It takes it out to the earth, and you got this high voltage transient. I mean, current charge is that lightning is a current driver, right? It's not a voltage potential. It just pushes electrons, creates a magnetic field. I'm like, well, how do I protect my stuff? He goes, you need surge protection. Put it on the service, put it at the panels, put it at your equipment, put it on your low voltage equipment. We talked about that with those little connectors. He says provide all kinds of surge protection, but make sure all your equipment is grounded and bonded together. I said, it is. He goes, there's something not right. So I'm looking around, I take a look at my satellite dish. Well, the satellite guy, he went to, I have like a little telephone demarcation section, which is a metal box. You know how you have the low voltage, Brian, these white metal boxes? So I go over there and I see there's a screw there. And I look at the cable from the satellite guy over to where the cable connects to the, and it wasn't even tightened. And this is, in the white cover, little tiny black mark. I'm thinking, that's not very big, but apparently that's not very good. And so then I get that fixed. I'm like, that's where it was. I still wipe out more equipment. I'm like, what the heck's going on here? So now, I don't know what to do. I did all I possibly can. I keep wiping out equipment. Then somebody sends me a piece of equipment they want me to test. You know, being Mike Holt, hey, Mike, I got this new product. I'd like to take a look at that. I know you, and I'm like, okay, whatever, fine. So I have to put it at my service. And this is a product that measures a neutral to earth voltage in case you lose your neutral. It'll give you an alarm. I thought it was kind of cool. I helped them design the technology. I helped them give it the currents and the voltages. So, I mean, I helped them with the concepts, give him all the information. He created it. Of course, I'm going to have to take it to my house. I take it to my house. And one of the things you have to have in order to get this thing to measure voltage, you need to have a reference point to earth. I'm like, oh, okay. So I go in and put it in my house, and I got a wire, you know, with a little tiny nail kind of thing that you're going to kind of, I mean, you got to connect, the wire, and I can't find my grounding electrode. See, I was really smart. See, I didn't want my service to look bad. So I made sure my grounding electrical conductor went from the concrete, the stem wall, went up inside the block into the back of my meter enclosure so I wouldn't have to see anything. And I'm thinking, oh, the cable guy found it, though. So I must have had something else. I didn't realize. I go to the cable guy. I pull the wire out of the cable guy. It was never connected. It was just buried, stick in the ground. I can't blame the guy because I realized there is no grounding electrical connection anywhere outside of my house. This is before the intersystem bonding termination. That little sucker would have saved me $10,000. So by having an intersystem bonding termination, my satellite dish could have gone to that. It's part of the electrical power. The coaxial cable would have connected to that. The telephone would have connected to that. So that where I'm living at, because see, the telephone is grounded by the telephone company. We mentioned earlier, the coaxial cable, it's grounded also by the cable company, but we're talking hundreds of feet away. And then my electrical system is also equipment grounding here. And so what happened was I had all these cables coming in, all connected at different points on the earth, bringing in my equipment, and that's why I wiped it out. So the intersystem bonding termination is to bring everything together. Now, once you leave the intersystem bonding termination and then you go into your equipment, now you again pick up difference of potential, because nothing is going to be zero. It's zero at that point, but now you run wires. So what do? At your equipment, you do what? You put a relocatable power tap, which is a power strip, plug it into the electrical power. It says cable in, cable out, satellite in, satellite out, telephone in, telephone out, and you plug all that equipment together into the same power strip so that everything is again referenced to zero to minimize the difference of potential. Surge protection at the service, surge protection at the panel, surge protection relocatable power tap. Does that mean I'm not going to wipe out my equipment if I have a lightning event? Nope. Just means, that's what we're trying to do here. Yeah. So that's what this is about. And that's what Eric was saying is, again,
Sure.
All right, I'm moving on to 820, the last article. It's really coaxial cable is all we're talking about. What are the rules on coaxial cable? Article 20 covers the installation of coaxial cable for the distribution of high-frequency signals typically employed by television, cable TV, and closed-circuit TV. If you take a look at 820, and a good friend of mine has been trying to get this title changed, he's saying, look, if you read the scope says this article covers coaxial cable distribution. But the title is Community Antenna Television and Radio Distribution Systems. That doesn't make any sense at all. So, it's the cables, all we're talking about here. Now, the N.E.C. requirement does not apply to the utility. So, if a utility is running cables, then that's exempt from the code. Just when you're running your own coaxial cable. 820.2, definitions. Coaxial cable, a round assembly composed of a conductor inside a metallic tube or shield separated by a dielectric material and usually covered by an insulated material. All right, coaxial cable, got it. That's a plenum rated one because it has P on it. Look at that, Brian. There's coaxial cable right there, composed of a conductor or otherwise, which in this case, these are not. If a separate electrode is installed or used, a bonded jumper must be run to the power grounding electrode system, and that conductor cannot be any smaller than 6 gauge. 820.110, raceways and cable routing assemblies or coaxial cables. Where raceways are used for coaxial cables, they must be installed. But in this will not get into those conductors that would be affected by you saying, I think, in other words, a really small amount of energy.
Oh, very small. Very
so
small.
now all of a sudden you get a transient, or you get this RF signal coming by inside there. Well, now you affected that signgle.
Yeah, in fact,
so
you can shielded Cat5 cable. If you still cannot run a shielded Cat5 cable anywhere near a fluorescent light ballast, and people make that mistake all the time. They're like, "Oh, but it's shielded." I'm like, "Yeah, well, that doesn't make any difference."
And what we got to remember is that when you run these shielded cables, you bring everything to one spot, and then you connect them all together at one spot of all the shielding. And then that then gets grounded. At the other end, you do not.
Holds true with the LED.
Only at the one end. Because what we're trying to do is take this energy that's like an antenna, it's being induced on this air, and then we're trying to, it's called equipment grounding. And all those things that are going to be repetitive. But then again, the only other advantage is that, I don't know. So maybe repeating it and going quickly like we've done, I mean, maybe it's not a bad thing.
Definitely not going to forget it.
Yeah, that's the thing. Repetition brings memory.
Guys, we're done. 2017.
All right. We gonna stop it right there. And like I say, we're gonna do the final exam B from page 437 to 446 in the Understanding the National Electrical Code, Volume 2 book, 100 questions, and you'll turn this in to me on December the 10th. Hope everybody stays safe and healthy, and just try to make it through this COVID and just do the best you can there. And I'll be sending you this video along with instructions. And we'll see you December the 10th. Thanks. Bye.